All right, let's get right into it. For the last couple of years, if you've been anywhere near AI, you've probably heard one thing over and over: prompt engineering. But while everyone was heads down mastering how to write the perfect prompt, the entire ground shifted underneath us. A new, much trickier challenge popped up, and with it, the need for a totally new skill. We're talking about context engineering. And this graph, it tells the whole story, doesn't it? See that massive red spike? That's prompt engineering just exploding after ChatGPT dropped. It instantly became the skill for talking to a language model. But look closer at that blue line, the one that's quietly starting to climb. That's context engineering. And its rise is happening right as we're entering what people are calling the year of agents. AI systems that don't just chat, they actually do stuff.
So, that really makes you wonder, right? If getting the prompt just right was the key that unlocked that first wave of generative AI, what's the master key for this new wave of autonomous agents? Well, the answer is all about solving a problem that these agents actually create for themselves.
And that leads us straight to what we're calling the agent's dilemma. See, AI agents are absolutely the next big thing, but they have this fundamental built-in problem. They're so good at generating useful information that they can literally drown in it.
So let's do a quick breakdown of what an agent even is. At its heart, it's just an LLM that can use tools, think a web browser or a file editor, over and over again in a loop. The LLM thinks, okay, I need to call this tool, it gets some information back, and then it decides the next move. The catch? Every single one of those cycles adds more and more stuff to its working memory, its context. And we're not talking about a small problem here. The team behind Manus, which is a really advanced AI agent, they say a pretty typical task can take over 50 tool calls. And Anthropic has mentioned that their production agents can have conversations that go on for hundreds of turns. Every turn, every single tool call just makes that context bigger and bigger, leading to this massive data explosion. And here's the paradox, the really weird part. Agents need all of this context to keep track of what they're doing and make smart choices, but the more information you cram in there, the worse they actually get at their job. It's a phenomenon that some people have started calling context rot. Now, this performance drop isn't just some vague feeling that the agent is getting slower. It fails in very specific ways. You have context poisoning, where an agent just makes something up and then wastes a bunch of time trying to use that imaginary thing. There's distraction, where it gets stuck in a loop just doing the same old thing instead of moving forward. Confusion happens when it has too many similar tools and can't decide which one to use. And clash is when it gets conflicting results from its tools, which can totally derail its plan. So, how in the world do we fix this? Well, this is where our new skill comes into play. The AI expert Andrej Karpathy defined it perfectly. He called it the delicate art and science of filling the context window with just the right information. The key isn't just to stuff more data in. It's about being a perfect curator. Okay, so how do we actually do that? Turns out, developers and researchers are already starting to agree on a few powerful strategies. So let's open up the engineer's new toolkit and see how we can tame all this context. Right now, there are basically 5 core strategies that are emerging. You can almost think of it like a funnel. First, you offload. You move all the bulky stuff like files out of the main context window. Then, you reduce what's left. You shrink it down. Next, you retrieve only the specific little bits of information you need right when you need them. You can also isolate different tasks by using multiple specialized agents. And finally, you cache the parts of your prompt that never change to save a ton of time and money. Let's zoom in on that reduce strategy for a second, because there's a really important difference here that the Manus team pointed out. On one side, you have compaction, which is reversible. Think of it like this. Instead of putting a whole document in the context, you just put its file path. No data is actually lost. But on the other side, you have summarization, and that's irreversible. It compresses the data, sure, but you might lose some key detail forever. It's super powerful, but you gotta be careful with it. Okay, so that's all the theory, but what does this actually look like in a real system that's out there performing well? Let's take a look at the Open Deep Research Agent. It's an open source project from LangChain, and it puts all these techniques into practice. So this agent has a really simple 3-stage workflow. First, in the scope phase, it figures out what the user actually wants. Then it uses a bunch of subagents to do the research, and finally it pulls everything together into a report in the right phase. Simple enough. Now let's see where the context engineering magic happens.
So right at the beginning, in that scopes phase, the agent creates this super detailed research brief. Now, instead of keeping that entire thing clogging up the context window, it uses our first technique, offload. It just saves the brief to an external file. This keeps the main context totally clean for the next phase, but the master plan is always there if it needs it. Pretty smart. Okay, next up, during the research phase, the agent is just going wild. It's making tons of tool calls, doing web searches that come back with these massive walls of text. To handle all that, it uses our second technique, reduce. It's constantly summarizing the important stuff from those tool calls, keeping only the absolute essentials in its working memory. And this is where we see our third technique. The research isn't done by one giant, overwhelmed agent. Nope. It's broken down, and it uses multiple sub-agents for each specific topic. This is isolate. Each one gets its own fresh, clean context window. This stops them from getting confused by each other's work and keeps the whole operation running smoothly. So, as you can see from this chart, these aren't just ideas floating around. These are real strategies being used by top-tier projects from places like Anthropic and Cognition. But what's really fascinating is they don't all agree. For instance, Manus loves offloading, but warns against reduction because you might lose information. Cognition, on the other hand, avoids isolation because it can get messy trying to coordinate all the sub-agents. It just goes to show you there's no single right answer here. This new discipline is definitely as much an art as it is a science. And that brings us to a final and, I think, really crucial insight. Context engineering isn't just a bag of technical tricks. It's really a philosophy about how we should be building with these incredibly powerful new models. At the end of the day, this is what it's all about. The goal is not to build more complicated systems. The goal is to make the model's job simpler. The biggest breakthroughs often come from removing layers, not adding them. From giving the model a clean, focused context, and then just trusting it to do what it does best. The Manus team has this amazing motto that just sums it all up perfectly. Build less, understand more. It's such a powerful reminder to not fall into the trap of context over-engineering, and instead to focus on creating clarity for the AI, not just building more and more scaffolding around it. And that leaves us with a really fascinating question for the future. As these underlying AI models get more and more powerful, as they get bigger context windows and better reasoning, which of these engineering layers, the offloading, the reduction, the isolation, which one of these are we going to be able to just throw away first? It's a question that's really going to define the next chapter of building with AI.